Well, hello and welcome YouTube. Mr. Robinson back here with yet another brand new exciting video, all math-based of course, and as always, it is an honor and a privilege to be serving you here today, as it is every day, here in my virtual classroom. Step on inside, let's do some math. We're going to be looking at volume of prisms and cylinders, a bit of a geometrical concept. It is 3D in nature, but you're watching it on a 2D screen, and you're going to have to understand the concept of the drawings a little bit. I'll give you a sneak peek preview of what this looks like as I do 12 practice problems with you. I believe it's 12. Now, in doing so, guys, you are going to... sorry, before I talk about that. Yeah, sneak preview-wise, see the dotted line idea? That's what's going on in the background, if you will, if you're looking through the object, if you have Superman X-ray vision, or if it's glass. But the point is, it doesn't confuse you too much with everything as solid lines. Hopefully you get a good gist of what that feels like. And if not, grab a box. And, you know, I didn't know what to get you for Christmas this year, so I got you this box. That's what I got you. It's something like that from SpongeBob. I forget what it was. Christmas, Valentine's Day, your birthday. Anyway, or anniversary. I think it was anniversary. Okay. You might want a calculator for this one, because what we're going to be doing with volume is a multiplication of, because it's three-dimensional, at least 3 items every single time. And sometimes we're taking half of them, and sometimes they're just not integers to begin with. So definitely have a calculator out. I'll be using my handy-dandy little on-screen calculator with you guys. Let's go ahead and get started with this one right here. The volume of prisms and cylinders can be represented with BH, where B represents the area of the base. Identify the type of figure shown and match the prism or cylinder with the appropriate volume formula. Yeah, so what they're talking about, guys, is here's a formula for volume. Area of base times height. Now, the B being capitalized means area of base, as opposed to just base length of like an edge length or whatever. And height is an actual length, maybe not of an edge, but the length, the distance between your two bases of your particular object that you're referring to. And I'll make sure to point out wherever those things are. But this is what I like to call out for my students, y'all. The volume is area of base times height. Your base is going to change each time, and you can focus on that one at a time per problem. So when you watch me practice these problems, guys, you're going to notice that I'm not going to plug them all in like this and like this and like this just as once, especially now that I look at 2 heights here, because these 2 heights, guys, these are 2 different things. I want to let you know right now, this height, what this means here and what this height means here, are not the same thing. So I'd much prefer that, you know, you don't have them all as one formula like that. Separate what the B and what the H are when you actually compute. There's actually nothing to often compute in height. But, you know, find the area base first and then put it in, and then you're hunky-dory. All right, I think that's going to help a lot more. But they are asking us to now tie it in with these things and give them a name, because if they give this, it's not enough information, and if they give the name, they just gave away part of the answer. So let's look at which each of these things are right here, guys. This right here, this is a prism. This is a rectangular prism by the nature of its bases right here and right here. Now, it's impossible to say for sure which ones are the bases of this rectangular prism, because you could identify these as the bases as well. They're still rectangles, and the lateral faces are still rectangles as well. And you're going to notice that it's not going to matter for this one, but it will matter for, you know, some of these ones here. Either way, guys, this is a rectangular prism. It does have rectangles all around. Okay. I want to do the Patrick rectangles, and I just did it, so there's that. Now, which formula ties in with it, A, B, or C? Well, the area of the base is area of rectangle. So look at this height, ignore this height for a second. Boom. Which of these identifies with the area of a rectangle? Is it pi r squared, 1/2 base times height, or length times width? The answer is length times width. And if you had a base times height, we could take that as well. But 1/2 base times height? No. The volume here is going to be length times width times height. Area of base of the rectangle, or area of the rectangle is length times width, and then times the height of the prism itself. There you go. Now, this one right here, it's not called a prism only because circles tend to give other names to things. And so therefore this one is actually called a cylinder. A different name we could call it is a circular prism, because it kind of has prism-like properties in a lot of different ways, but it has circular bases. So we call this one, guys, a cylinder. That's what a circular prism is. It's a cylinder. And that one is where we use the area of the base, which is a circle, times the height. That's pi r squared times height right there. So volume is pi r squared h. You will see me every so often say or write pi r squared h just because of how it naturally comes up in circles as opposed to the other things, but it is still area of base times height. And this height, guys, is represented right there. That is the height of this thing. Okay, the last one here is, it's not a pyramid. We'll talk about pyramids in my next video on this subject matter. I think that's what comes next, and then cones. Maybe I can have them both on the same thing. But this is still a prism because here's a base that's a triangle, and here's a base that's a triangle, and in between those two are rectangles. You see this rectangle right here? You have to imagine this in 3D. But you see, you know, like a house of cards. You see that card laying up against this card right here? And then there's a base card right there. These are all rectangles meeting with those two triangles. And the triangles are actually the bases. It doesn't matter that the bases aren't on top and bottom on this thing. All you got to do is tip it back upward, and then they're on top and bottom. The triangles are the two unique shapes that are separated by rectangle lateral faces here. So this is what's called a triangular prism. And I never imagined that I would spend a lot of time on these three problems, but I think that this helps identify what it is you're going to be doing the rest of the way. And so I'm totally cool with that. So the... well, here, I'm going to write out the formula, and then I'll talk about why these two h's are not the same. So the process of elimination shows that it's this one, 1/2 base times height, which, by the way, is the area of a triangle. So area of base times then height. And voila, we have the volume of a triangular prism. Now, why are these two heights not the same? Or not why are they not, but where do these two heights exist? Well, I couldn't tell you for sure where this one is because we didn't identify what our base and height length are in the triangle bases. But let's say, for the sake of argument, that this front triangle has a base length b literally down at the bottom right here, and then therefore its height is always perpendicular to your base, even if abstractly drawn like this. And we're going to actually have to talk about that later with oblique cylinders and prisms. So that height would be right here. That is this guy right here. That would be its height of the triangular base. But the height of the prism is the distance between your two bases. That is this. That h right here, that is that height. Those are two different numbers. They could be the same number, but those are two different things right there. It's not even the same h. So it's really important to note those two differences. That's why I'm going to do area of base differently from when I do it with the whole volume and the height right there. So I wanted to make sure that you very well knew that. All right, let's move forward. Numbers 2 and 3. Find the volume of each prism or cylinder, round to the nearest hundredth. Now, both of these actually are prisms. I got a rectangular prism and triangular prism. Why are they rounding? Come on. Okay, fine. All right. Rectangular prism. I'm going to identify the bottom here as the base. Bottom and top as the base. And they're both, in a prism, guys, the bases are the exact same figures. All right, they're congruent to each other. So whatever one base is, the other's going to be. So the area of this volume is area of base times height. That's always going to be established. So I'm just going to go ahead and put it right here. So the area of the base of this one is the length times the width. It's 8.4 times 3.5. And that's where I'm going to jump to my calculator. Even though I could work on that, but I'm not going to know it off the top of my head. So let's go to the graphing or my calculator here. Let's do 8.4 times 3.5. I don't want to be wrong. So it's 29.4. So that is 29.4. And by the way, y'all, we have units. That's square millimeters. When you're talking about area, millimeters times millimeters or square millimeters. And we're there. Not the full and final answer, but there's that. I'm going to identify the height for y'all. That's going to be 5.6 millimeters. It's the one that was not touched yet. So our volume, when we do area of base times height, it's going to be 29.4 times 5.6, and that will equal something. It's going to equal probably around 170. Around 170 is my guess. Let's check. Because I'm trying to do 30 times 6 when I do that in my head. Probably a little more than 170. I don't know. Let's see. 164.64. Okay. Now they said round to the nearest hundredth. That is to the hundredth. So 164.64 cubic millimeters now. That is the entire volume of this thing. And volume, if you guys don't know, I should have really mentioned this first. If you don't know what volume is, area is how much coverage there is on a two-dimensional object. how much paint would it take to paint that whole thing? Oh, 29.4 square millimeters of paint. Volume is how much space is occupied, right? It's not about cover, it's about fill. If I could take a bucket of paint and, fill it up with this, how much is filled over here? You need 164.64 cubic millimeters of paint, of water, of sand to fill up that entire thing. What are cubic millimeters? Well, I don't know. But the point is, you could pour that into something else that's 164.64 cubic millimeters. That's a completely different shape, and it would still fill it to the brim. Doesn't matter if it's this shape or a cylinder or something like that. But that amount stays the same as long as everything with the same volume is like that. And if it's in that liquefied state. All right, number 3. We have, and this is an example of one of those triangles I was talking about, right? It's a triangular prism, and my base triangle right here, I can find its area using this base length and this established height right there. So in this area of base times height, let's start with the area of base. Area of a triangle is 1/2 base times height. So 1/2 base length is 9, height is 15. That's height of triangle, height of my triangular base there. I'm going to try this one in my head. 9 times 15, I don't even know. 135. Half of 135 is 67.5. Yes. So area of base is 67.5 square yards. So I started with that. Now that height's there, the height of the prism, the triangular prism is 12 yards. Okay, so the entire volume now is going to be that area of base times height, 67.5 times 12. And I really want to try this one in my head, because I'm going to go back to 67.5 times 2, which is 135. So instead of multiplying that, now we got to multiply that by 6. Oh, man. 270 times 3 is 810. I think it's 810 cubic yards. Let me type that really quickly. 67.5 times 12. That's 810, yeah. That's me stretching out my own brain for my own sake. I want to be able to do that for myself. It does nothing for you. It's only for me. Now, you should be using your calculator anyways. You're practicing. You're using me as follow-up or learning tools, but always double check your own things. I'm prone to make mistakes. All right, numbers 4 and 5, guys, they do not have images. This is number 6, this is number 7. These do not have images. This says the area of the hexagonal base is, whoa, this weird number. Its height is 8 meters. Now, a hexagon, they're talking about a prism. A hexagonal prism would look like a hexagon, of course. 1, 2, 3, 4, 5, 6. And people always like these, like, oh, that's cool. Or as my nephew would say, that's fancy. He's like 4 years old. That's fancy. So like that, right? So I have a hexagonal prism here, okay? The area of the base is this crazy thing. So they're saving you from doing the gritty work on this thing, only we're going to have to work with a calculator here. You don't need the drawing. I'm just giving you what they're talking about. So the volume is still area of base times height, though, right? So this is B and this is H. All we have to do is a substitution. So volume is area of base, 54 over tangent of 30 degrees, times the height, which is 8. And then bada boom, bada beam, we're going to get an answer. This is where we round to the nearest hundredth, because tangent of 30 is going to be an irrational value, as it's 1 divided by the square root of 3. So that's not pretty. Okay, so let's go to the calculator here. Now, one thing you want to do in your calculator that I have to do in mine now, because I know it's defaults to radians, is you have to find your mode option or setup or whatever it is, and you have to make sure that your calculator is set to degrees. If we're going to use degrees when we do our trig functions for a tangent of 30 degrees, we have to be set in degrees, or our answer is going to be way different, and for a way different reason. So I'm going to be doing 54 over the tangent of 30, and then I'm going to multiply that by 8. And I don't know if they're getting you to practice things like calculating like this and understanding that you're going to get answers like this sometime, but it is really important, guys, that you do write an exact answer before you do an approximated answer like this. I probably should have done 54 times 8 first and written that out as 432 over tangent of 30 before even writing this. Either way, this is our answer here. 748.245, that's going to be 0.25 when we round up. So 748.25, let's do approximately, 748.25 cubic meters. And that's your final for number 4. Oh, I need the height right there. Okay, number 5 looks like it's doing the same thing. Pentagonal prism. I'm going to not draw it, but I'll tell you, a pentagon is 5 sides. A pentagon is 5 sides, and then the prism goes from there. So same thing, guys. Volume is area of base times height. Let's check it out. Area of base is 125 over tangent of 36 degrees, and then times a height of 15. Sorry, that chugged a little bit. So let's go back to the calculator with that. Just make sure, again, you're in degrees when you do it and you're not in radians. So that's 125 divided by tangent of 36. And all that times 15. And that's going to give me 2580.72 as they kick it up. They rounded up to the nearest hundredth there. So 2580.72, once again, cubic meters there. And again, no drawing on those ones. Simple substitution and go. All right, numbers 6 and 7. We now have what are called oblique prisms and cylinders. Oblique just means slanted. And there's nothing necessarily too daunting about this unless there's information not given. But the important thing to note is when you refer to height, and this is not just true for, actually here, I mentioned this before. Remember a triangle? Remember, I can't draw today. Remember a triangle? I mentioned that if your base is some side length, your base has to be a side length, right? The height is always perpendicular to the base that's established. Always. So perpendicular can be an abstract length such as this. It's not a side length in this case. It's something that just reaches the tip perpendicularly. Even one that goes obtuse like this. If this is your base, your height is right here because it's what goes perpendicularly to the base. It's not this. It's not a slant height. No. And we might refer to slant heights later when talking about surface area of cones and pyramids. But here, heights are a perpendicular, and you can see it right here. This perpendicular distance between your bases, and that way you know that this is established as a base. This is your base, and this oblique rectangular prism right here establishes 6 centimeters as your height. So if they don't give it to you, you're going to have to find a way to find it. It's likely through Pythagorean theorem or something. But if they give it to you, that's what we established. So guys, your height is 6 centimeters. And by the way, what I wanted to mention about all this is the volume is unchanged. It's still area of base times height. Just know that the height is perpendicular. It's not a slant height. All right. Area of base. With the right angle symbols right here, we do know for sure that this is a rectangular prism. That means we get to play length times width. So area of base is 9 centimeters times 4 centimeters, which is 36 square centimeters. So the volume of this oblique rectangular prism is going to be area of base times height, which I think that's 216. 6 cubes, yeah. 216 cubic centimeters. And there you go. I'm done. And now I actually change the color because I just used green there before. Give me 1 second here. I need to lock some parts in place. All right, let's change. I want to use all my goal is to use all different colors on this page. Let's use a darkity dark blue. I haven't used black yet. All right, number 7. Now, okay, this is our first cylinder. Now, they did ask us to round to the nearest tenth, or hundredth. Sometimes they say leave your answer in terms of pi. What you're going to have to remember here is that we have that whole pi r squared thing with area base times height. Our base is pi r squared. So radius and pi. Sometimes they say leave your answer in terms of pi. Sometimes I'll be asking that of my own students there. But we're going to round to the nearest hundredth in this particular case. So we're going to go to the calculator for that part too. With pi, we'll press the pi button. We won't round 3.14. All right, now the height is 10 feet. Height is 10 feet. That is nice and clearly established. The area of the base, however, we got to use pi, we'll use the pi button on the calculator, times the radius squared. Now, radius of a circle is half of its diameter, and they established the diameter is 12 feet. So half of that is 6 feet. So your radius is 6, and we're going to square that, which isn't 12. That's 6 times 6, not 6 plus 6. That's 6 times 2. All right, so that is 36 pi And like I said with that trig stuff from before, it's better to write an exact answer before rounding it. So I'm going to leave this as 36 pi for now, and we'll get to, I don't want to round early. I don't want to round early. That's part of my, shtick right there. So the volume, area of base times height, is going to be 36 pi times 10, which is 360 pi cubic feet as an exact answer, but they want us to round that thing. So let's go ahead and do just that. Let's go back to the calculator here, and let's do 360 times, I forget where my pi button is. You should do a pi button right there, and we get this 1130.97. 1130.97 cubic feet. It's approximately there we are. All right, so hopefully all this is making sense. I know that was our first aspect of seeing a cylinder, and it was an oblique cylinder. I hope that's okay. But yeah, we'll go and move on from there. That was the first 7 problems. I still have 5 more to do. All right, here we go. Number 8, multistep. A vase in the shape of an oblique cylinder has the dimensions shown. What is the volume of the vase in liters? Oh, liters? Oh, wait, I think liters are cubic centimeters. I hope that... Is that right? Hang on, I'm going to look that up. I don't remember. Hold on. All right, I'm back. Apparently 1 liter is 1,000 cubic centimeters. I kind of wish... I didn't even know that was a part of this question, so I kind of wish they didn't ask that. Maybe that's a part of the multi-step thing. So we'll do that conversion later, but my more important thing will be the cubic centimeter portion first, and then we'll divide by 1,000. Okay, so vase in the shape. All right, so now they're giving us a hint there. They say use the right triangle in the cylinder to find its height. And this is important because the 17, guys, is not the height. That is its slant height. That is as, reaching diagonally to there. But again, distance is perpendicular to your bases. In this case, it's literally the bases, the circles right there. So we need to find this. This is going to be our height. Now, the diameter of the circle is 14. Let's just do the height first. The diameter of the circle is 14, which is also one of the parts of the right triangle here. The height is another leg of the right triangle, and the 17 is the hypotenuse of the right triangle. So this is going to say h squared plus 14 squared equals 17 squared, which is h squared plus... h squared plus 196 equals 289. I'm rusty because I haven't done math in a few months. At least not this kind. H squared is, don't make me do math, 93. Ugh, is that right? So h is the square root of 93. Tell me that's correct. 90... I think so, 93. Now, I'm going to leave it like this, guys. I'm not going to round this early. Once again, that's a huge and important practice. I'm telling this to my students right now. Guys, it's a huge important practice. Do not round your numbers early before your final answer. Use what you got in the calculation as best as you can. So there's 93, square root of 93 centimeters for the height. Now, the area of the base, once again, is pi r squared. And once again, this 14 here acts as a diameter. Hold on, root 93. This acts as a diameter to the circle. That means that the radius is 7 centimeters. So the area of the base is pi r squared, which is 49 pi square centimeters, like that. So both of these together, this is where we now do volume. Volume is area of base times height, and we get something. So I got to type all that out. I can do 49 times pi times the square root of 93. I bet if I just type those out, 49 pi root 93, without a multiplication symbol, I think it'll still work. I'm going to try it. 49, let me clear this out. 49 pi times root 93. It should imply multiplication throughout. It does. 1484.52. This is still part of the same instructions as rounding to the nearest hundredth. Now this is 1484, approximately 1484.52 cubic centimeters. And by the way, this actually isn't the final answer because they wanted this in liters, and if I Googled it correctly, 1 liter is 1,000 cubic centimeters. So I need to divide this by 1,000 to get 1 liter. out of that. Is that right? Do I multiply by 1,000? Do I divide? I'm suddenly blanking. You divide, right? So this many cubic centimeters there is 1 liter. Sorry, I felt the sneeze coming on. Okay, so volume then, that is 1484.52 divided by 1,000, which is 1.484 blah blah blah. But they still want to the nearest hundredth, so I'm just gonna do 1.48. Not cubic centimeters, liters. That's whatever. This is fine. I barely even noticed that was shown up there. All right, guys, numbers 9 through 12. These are the last 4 problems that I'm going to do. These are all what are called composite figures. Now, that's not too bad. All it means is you just got to add together or subtract from different parts of these after identifying the shapes. It might take a moment, but don't make it more confusing than it actually ultimately appears. Just treat parts separately, okay? So what I'm going to do to keep these separate is I'm going to find volumes of parts in separate ways, okay? So I'll call this, like composite figures is your regular figures that you talk about, and then they're either on top of each other or removed. So I'm going to call this shape 1, and I'll call this shape 2 right here. So when I find the volume of shape 1, I'm going to be doing something different than when I find the volume of shape 2. All right, and then area of base 1, things like that, height 1, yada, yada, yada. So I don't know why I wrote those already, but let's start with the cylinder right here. The cylinder has a radius of 4 feet. What's this 12? Uh-oh. I think the 12 is this right here, because that's 4 right there. Okay, the radius is 4 feet. The height of the cylinder is 4 feet. All right, so the height of the cylinder is 4 feet. The area of the base of this one is pi times the radius squared, which is 16 pi square feet. So the volume of the cylinder, excuse me, is the area of the base times the height. So that's 64 pi cubic feet. For now, and that's not the final answer, but that's that part. For now, I'm going to leave it like that. Again, I'm not rounding until the end. Leave it until the end, please. All right. Volume of the rectangular prism. Now, you might, because the cylindrical, because the circle is sideways, you might call this the area of the base. And if you want to do that, that's totally cool. We can deal with that. But some people might call it on the bottom right there. Yeah, let's just do the area of the base is just this guy here, just to think about this as like a shape that it's like toppled over. So I have the 14. Okay, so this is 12 here. So the area of the base is going to be 12 by 14. Okay, and then the height of it is 6. All right, I hope that's okay. So the height of the rectangular prism is 6 feet, and the area of the base is 12 times 14, which is 168 square feet. So the volume of the rectangular prism is 168 times 6, and sorry, I'm going to try this one in my head. 1008. I'm going to try that. Or I'm going to calculate that. Oh, not divided by times 6. Woohoo! All right. 1008. So that's 1008 cubic feet. Okay, the volume of the entire composite figure is, here's where I use black, is going to be the volume of one plus the other. You just add up the volumes, right? It's just one on top of the other. So it's going to be 16 pi plus, which is around 50 something, or plus 1008. And this is where you get to round ultimately after computing. Oh, no, I'm sorry, 64 pi. 64 pi, my bad. I was just looking at the area of the base. I should look at the boxed part, right? 64 pi, which is around, that's probably around 200. I was wondering, I was looking at that, I'm like, that's not really to scale then. So this is going to be about what? It's going to be around 1200 something. So here we go. 64 pi plus 1008. And round to the nearest hundredth, that is 1209.06. 1209.06 cubic feet. Now, it stays as cubic feet. Cubic feet plus cubic feet equals cubic feet, just like feet plus feet equals feet. When you multiply is when the dimensionality changes, right? That feet to the 6th power. But we're adding there, and that's your final answer there. All right, guys, number 10. Now, this drawing, this is my first time seeing it. Or at least trying it out. My gut feeling is this is like a toilet paper roll, that it's hollow on the inside, right? Or not on the inside, but like this part right here. Otherwise, if that was just another cylinder there, then you're just adding up the whole big thing. But I'm imagining that this part's empty. So what they want is the volume of everything around it, like the toilet paper, you know, not the inside part. So this part's hollow. So here's what we're going to do. I'm going to call it, the volume of the first guy and the volume of the second guy. We still want to find both volumes, but instead of adding them, we actually want to subtract them, right? We want to take out this volume from our shape, and then we're left with everything else. That's going to be the ultimate goal. When I find the volume of 1, when I say 1, guys, I'm referring to actually the whole thing. I'm not just referring to the brim. The brim is what we're going to find in the end, but I'm referring to the volume of the whole thing when I call volume 1. I hope that makes sense. And then I take out volume 2, and then that's what remains. So, with regard to that, 10 inches is the radius of the larger cylinder. And the height is 15 for both of these, just so you know. There are faster ways to do this problem that I'll leave out because you have to kind of be tricky with it. So let's find the volumes of both separate parts and then subtract, and then we'll be good. Now it is cylinders, so pi r squared is the area of the base here. So the area of base 1 is going to be pi times 10 squared, which is 100 pi square inches. And then the height of that bigger cylinder is 15, just like the other one is 15 inches. So the volume of the larger one is 100 pi times 15, which is 1,500 pi cubic inches. I'll leave it at that until I add in the end. All right, the second one, let's use that red. All right, the second one, the inside one, now here's what some people might think. They might think because it's half the radius, it's going to be half the volume. Not true. Not true. It's actually going to be a quarter of it. But here we go. So the volume, so it's not going to be 750. It's going to be 375 pi, I think. So the volume, I think the volume, the area of the base of the second one is pi r squared, 25 pi square inches. Hang on a second. Let me see what I just got here. All right, the height of the second one is 15, once again. So the volume of the second one is area of the base times the height. Is that 375? 25 times 15? 15 quarters. Yeah, $3.75. Yeah, so 375 pi cubic inches. I don't have much room for the last part of this because this one's getting in the way, but the volume of the entire thing is 1,500 pi plus 375 pi, which is 1,875 pi cubic inches. That's an exact answer. As an approximated answer, sorry for leaking it into there, as an approximated answer, it's going to be, just hopefully you can take my word for it, I'm computing this one, 5890.49. 5890.49 cubic inches. There we go. All right, that was for number 10. I got two more composite figures here, and then we're set to jet. All right, we have cubes. we have cubes. Cubes are not just square prisms, but they're square prisms with square lateral. Everything's a square. Everything's all congruent faces all around, and there are 3 of them. So now, just the volume of a square. I'm just gonna. It's still area of base times height, but even better, it's because they're all the same numbers. It's something times itself times itself. So the volume of a square, I will put this one up uniquely just to kind of save time. It's every side length cubed. That's an S, not a 5. Every side length cubed. So let's call this cube 1, cube 2, and cube 3, and just kind of make it fast. So the volume of cube 1 is going to be 4 cubed, which is 64 cubic centimeters. The volume of cube 2 is going to be 6 cubed, which if you heard me before, I said 216, which it is 216 cubic centimeters. And then the volume of cube 3 is 8 cubed, which is, do I know 8 cubed? 512 cubic centimeters there. So the volume of the entire thing is going to be all 3 added together, of course. That's going to be 64 plus 216 plus 512. I'm going to try to do this without a calculator. 64 plus 216 is 280 plus 512, I should be a lot faster at that, is 792 cubic centimeters. I hope I did the math right, but the idea is in place. So hopefully we're following along with the idea. You can calculate for yourself and see how I did and see if that's okay. All right, number 12, the 2 figures on each end combine to form a right cylinder. I kind of wish they just said they were semi-cylinders and that you could kind of figure out the rest for yourself. But yes, remember guys, these objects can be moved any which way you want. The volume shouldn't change when that happens. If I wanted to redraw this so that this rectangular prism was separated from those 2 semi-cylinders, sorry how I do draw this, I'm just going to try and trace all of it and drag it out. But if this is not drawn very up to snuff, but if I separated this from the semi-cylinders like this, boom, so I have that. And then if I drew this and connected it with the other semi-cylinder, well, guys, you end up getting a full cylinder. So I'm going to get this one here, and I'm going to go and connect it with this one here. And what happens is you do get a full cylinder after I've kind of detached everything up. So, and I take this one, and voila, look at that. It's a full cylinder. It's kind of drawn kind of strangely, but I do have a full cylinder. So, I mean, really, we're doing the volume of this plus the volume of that. That's kind of all I'm trying to say. Is you're trying to do those. You don't have to take the volume of half of one and then double it and do stuff. Just kind of imagine that it's one large cylinder. Okay, that's kind of the idea. So, when I start referring to volume of some parts here, I'm going to be doing the volume of 1 plus 2, and the 1 will be the rectangular prism, and the 2 will be the cylinder. Not semi, but the whole thing. Just imagine it's one cylinder. You know what I sometimes do as well, guys? It's like volume of sill, things like that, but I'm giving them numbers because I have the drawing already kind of made. So the volume of the rectangular prism here, I have 4 feet going across right there. So that's going to be 4 right here. So the area of the base is going to be 12 times 4. And the height is also 4 right there. So the area of the base of the rectangular prism, it's going to be 12 times 4, which is 48 square feet. And then the height of the rectangular prism is 4 feet. So the volume of the rectangular prism is going to be area of base times height, which is 192 square feet. All right, the 2 is the full cylinder, right? Everything. So the 4 is the diameter, if you will. Oh, here it goes. The radius is 2. So pi r squared for the area of the base. And then the height, I've used a lot of blue on the bottom, sorry. The height will be 4 of the cylinder, just like before. So the area of the base is pi times the radius squared, which is 4 pi square feet. And then the height is 4. So the volume is going to be the area of the base times the height. My picture's getting in the way. times the height, which is 16 pi. That's about 50 square feet. 16 pi square feet, like that. Oh, cubic feet, excuse me. Okay, so we're going to do 192 plus 16 pi to get the last thing. It's going to be around 242. I can already say that because I think this is right around 50. So, oh, I put square feet here as well. That's totally my bad. I was just in the square foot kind of thing. Let's use black for this part. The volume is going to be 192 plus 16 pi, which is about, oh, you know, graphing calculator. 192 plus, you can see my other calculation as well. Oh, now you can't. 192 plus 16 pi equals, so 242. 0.26, 0.27. 242.27 cubic feet. And there it is. All right, so you're getting the gist of that, guys. When we start hitting, and that's it, and that's all. When we start doing some of the other things, cones and pyramids, I think pyramids first, pyramids and cones, you'll kind of see the relationship that it has with prisms and cylinders. And hopefully some of the other nitty-gritty stuff I said, like do not round early and understanding how rating, like all that kind of stuff works. Hopefully I can go a lot faster with that, just understanding that you kind of saw this video first as a prelude to it, and then everything else kind of falls into place, and how I find the area of base first, stuff like that. So that ought to do it for this one, guys. This is Mr. Robinson. Thank you so much for watching, and take care.